thank you for coming and listen to how you can protect your website, your service, or whatever you have on the internet with some Rust. Before we begin, I would just want to tell you a short story that happened to me a couple of months ago. I was at a birthday party with lots of people, most of them non-developers, but there was one old friend of mine that was a developer, and I was super excited because I created something like this that I'm about to present for one of our clients. Coded some Rust with Pingora, used it to protect one of our clients' websites, and it had a massive effect. And I was super excited. But this friend of mine looked at me very seriously and told me that you don't talk about web application firewalls at parties. Because apparently it's the worst party pooper topic you can think about. So I'm sorry if I'm going to bore you now, but let's see if you find this interesting. So my name is Camilo Tapia. I work at 24. We are a strategic tech agency or tech partner here in Malmö. I'm the CEO, but I am a developer. I've been a developer since I was 13 years old, long time ago. And I've been a Node fanboy since forever, since it came out. I thought it was super interesting how it changed the world, the way we thought about programming back in 2010. But since a couple of years ago, I would say I'm more of a Rust fanboy. So I will mention Rust quite a couple of times, even if I know that the title said that you don't need to know any Rust. I will show some Rust code. And I don't know how many people here have used Rust or looked at Rust at some point. Ah, well, a couple. Well, that's good. So you recognize some of the things. So let's begin with why. Why do we need to protect everything we have on the internet? And I know this is there's obvious answers to this, but I'll go through some points anyway. And the world looks as it looks today, which means that whatever we put on the internet, it doesn't matter what it is, everything will be scanned, it will be crawled, it will probably be scraped as well. Everything. And this happens super fast. It actually happens so fast that I was curious about how fast is it after you put something on the internet? How long does it take before you begin to see malicious or suspicious requests? So I created a website for our cats, which of course is the first thing you do. I put it on the internet, and as soon as I had the SSL certificate in place and I could see the last request I did, just to check that everything was running, I could see that about 50 seconds later, the first request came in. That is not mine. I don't have GraphQL on my cat's websites. And after that, there came a lot of other things as well. So 50 seconds, and it got scanned by a bot. And it was obvious that all the requests that were coming in were trying to find things. So there are two things we can take away from this. One is the obvious one, that it's as easy as it can be to be a hacker or using bots to find vulnerabilities. There are lots of different tools to use, which are quite good tools actually to use when you're developing as well. These are just a few of them. I've learned to use quite a lot of them by using a service called Hack the Box, which if you haven't tried it, it's super fun and you get paranoid. But again, there are many tools and there are many bots, and all these tools are used to try to figure out what you're running on your server. So are you running a certain system, a CMS, which version? And if they can find that version and they can find the CVE, then you're screwed. So fixing security is quite simple. It's easy to fix, keep everything up to date. We all know how easy that is, especially since we all have legacy code. And by legacy code, we could mean legacy code that is like 6 months old, because you suddenly introduce a package that requires you to update something, and that package is dependent on something else that isn't available anymore. And then, yeah, you know how it is. But there is one more thing. There were two things I wanted to talk about. Security is one, and the other one is the resources. Because every time a bot tries to scan you, they will not just do one request, they will do a couple of thousand requests. They don't care how much you can tolerate. They will just try as much as possible, which means that you either pay by buying more resources or by letting your customers take the damage by having a worse experience at the time where a bot is scanning you. So that means that we can do some things. I mean, the obvious thing is, of course, try to stop as much as possible. And if you're running your servers on the big cloud providers, then they have web application firewalls that will do a lot of things. Some of them are better than others. But we are seeing today, for different reasons, that some of our clients don't want to use any big cloud providers, or at least those cloud providers anymore, because they want to have their servers not only on European countries, they need to be owned by European countries as well. And for other reasons, you might have your server somewhere where you don't want to use a web application firewall provided by the big companies or alike. So you can buy a separate product, and there are many products that will be much better than what I'm going to show you right now, at least the small subset of things you can do in very short time. So these might be overkill for some reasons and expensive, of course, and you can always do it yourself. And from one perspective, doing it yourself is a good idea because you know what your application sees as normal data. You know the flows, you know which paths should be available, you know what should be accepted, maybe much more than a generic product that you buy. And it's quite easy to implement. You don't need Rust or Pingora or whatever to create the things that I'm going to show you, but doing it from scratch can be risky because you might miss parts of it, because the performance is very, very important. It's nice to have something to build upon that has been battle tested, something that at least gives you some ground to work on. And even better if it's open source, even better if it has like 40,000 requests, internet requests per second, whatever that means. And of course, I'm talking about Pingora, and Pingora is a crate in Rust, so it's like an NPM package for those of you that haven't tried crates. So it's not an application, it's a module you can use to create something yourself. So I would say it's similar like something like Nginx, a reverse proxy, but instead of being configurable, it's programmable. So you can put whatever logic you want into it. And it's written in Rust again, which means that it's memory safe, super efficient, like C++ performance, and it has modern tooling and quite a couple of modern ways of thinking, which at least for me were a surprise. I found things in Rust that I didn't know you could use or that even existed, concepts that are different, that require you to think differently. And just for that sake, it's super interesting. And I know Rust has this rumor of being difficult or complex, and I would say that it's not true. I think it's different. And of course, if you want to learn Rust to code everything that Rust gives you, everything from like websites to embedded systems, then it takes a little while. But if you want to use it for web backend or application firewalls, it's just a subset of everything, so it's not that complex. And I've shown this graph before. This is a completely unscientific graph that I created myself, so there is no connection to reality at all, but it illustrates something. So if you know JavaScript, then Rust takes a little while to learn. If you know TypeScript, it's a little easier. You know the typing systems, you know generics, etc. If you know C#, it should probably be higher up, but it's further up. And if you know something that is much more difficult than Rust, say like Vim, then Rust is nothing for you. So with that said, what we want to do is something to protect you. You want to put something in between the request and your application. And the only thing, Pingora has a lot of life cycle functions. So when a request comes in, there are many functions that can be called. I won't show you, I will only show you two of them because those are the two most important ones. And we'll begin just by creating a super simple proxy. Nothing fancy, nothing that gives you real value, but just a beginning. And for those of you that know Rust, this is obvious things. You create a new project in Rust by saying, writing this command. that will give you a folder with a couple of files where cargo toml is the dependency file and some other things, and main RS is where we'll put some code. Then we'll begin by just adding some dependencies, in this case the Pingora crate and some additional Pingora crates created by Cloudflare. I forgot to mention it's Cloudflare that has done Pingora, so they have quite a lot of knowledge about doing requests and proxies. So Pingora, Pingora proxy, Pingora core, and async trait. I won't go into that one. You need that in Rust to do async code sometimes. And this is everything we need. So we're just saying, okay, let's use some of the dependencies we just imported. And for those of you that haven't looked at Rust before, and for those of you that have looked a little at Rust, you might wonder why it has to look so ugly as it does. You have snake case, camel case, double colons. You have so many different syntax things that at least I know my colleagues felt that Rust was super ugly in the beginning. But after a while, you begin to understand why you have it. And after a while, when you get back to whatever language you were using before, you actually miss all the syntax. So anyway, import the things that you need or use them. Create some structs that are like classes or objects. In this case, they're empty. We need them anyway. A context that is empty and the proxy itself that is empty. We implement a trait that is like using an interface, implementing an interface, where we need to say, how do you create the new context? And we need to say, to use this part, which is one of the functions that are going to be called when the request comes in. And the only thing this does is tell, in this case, the reverse proxy, where to do the request to the underlying server. So this is where your solution is. And that's it, just return this. And with that, we just start the server, we create an instance of our proxy, and then we just connect it to whatever port we want to use, and we run it, and that's that. I think, I don't know how many rows it is, 27 rows. And we compile it, and compiling takes a little more time in Rust, it's known for. And I've done it here as a video, because you all know that if I run this demo live, it won't work. But basically, we just compile it, and when it's done, and I cut the video, it takes too much time otherwise, and you request the page, you get whatever is on the other side. So in this case, just the same site I showed you before. And as you can see, every time I reload, you see a text popping up. Nothing fancy. We haven't done anything of value. We have just created a small proxy, reverse proxy, nothing more. But on this small computer, this is not a fancy laptop, this proxy can take around 45,000 requests a second, which means that it doesn't take many resources. Whatever you have on the other side, whatever you're serving, as long as the other part is dynamic, this will not be the bottleneck, which means that you have a lot of space to put a lot of logic into it to create whatever protection you want to create. So let's do one more step. Let's create an IP restriction. And an IP restriction, if you put one IP restriction, I would never say to do it here, put it on the firewall, but just as an example. An IP restriction requires us to take a look at the other function in Pingora that we're going to use, one called request filter. And that's a very simple function. It takes a couple of arguments in, a session, a context. I won't go too much into those. The most important part is the result, what it expects to get out of it, the return. And in Rust, you can't throw any errors. You can only return something that might be an error, which forces whoever requests, calls this function to check for those values. So we need to return a result of type Boolean. So either this function will return an error or an OK value with a Boolean. An enum in Rust can have values inside it. So the only thing we want to return here is everything went OK with a false value, or everything went OK with a true value. Returning OK false means that we won't stop the request. It will go further on to the system and behave as if we didn't exist. Whereas if you return true, we stop the request. So this is basically what we have the tools we have, if we say, okay, true, we stop the request. And we can create whatever logic around this to stop it. So to create an IP restriction, it's just a matter of extending our proxy and saying, okay, we have the same code as we had before, where we want to be to reverse proxy our request. We insert the request filter. We check the IP number, which takes a couple of rows. And this might seem a little overcomplicated just to get one IP, but that's how it is. This will return an option type, option enum with either an IP or none, which we check here. We're forced to check for both situations, meaning that you either got an IP or you didn't get an IP because it couldn't recognize the format. So in that case, here, just for the sake of example, we say unknown. And the only thing we do is we check if that IP is my local IP, just to show you how this works. And if it's my local IP, we say, okay, send something and return, okay, true, stopped. Whereas if it's another IP, we just say, okay, false, and everything will go as expected. And as you can imagine, this code means that when I visit the site on my computer, I will get something. I don't think you can see it, maybe, but it says, no, you can't access this. Again, nothing fancy. One IP number, you put that IP number in the firewall. But this gives us some other options, which are more interesting, because now we have the tools to begin to stop, for example, bots. And stopping bots is something that we could use, just say, analyze the user agent, check if it's a bot or not, but that will not give us much because malicious bots will not reveal themselves as bots. So what would be much better if we could have a list of IP numbers that are known to be malicious, for example, and preferably something that is updated all the time. And sometimes the internet is a good place, and someone has created a repo for these kind of things. So there's a repo that is actually updated a couple of times a day, with a list of, well, a couple of different lists. One of being malicious IPs, 10,000 IPs. And it's super simple to use this. So we'll just put some more code. We'll say, okay, here's the URL to that list if we want to download it from the internet directly. In this case, we'll download it when the application starts. You could do this with a cron job. It's downloaded now and then. We request it, we fetch it. Request is the name of almost fetch in Node, for example. So we say, okay, do a request, unwrap it. Unwrap is something that you never use in production because that means you assume everything went okay. But this is example code, so that's fine. So fetch it, get the body, unwrap that as well. Take that body, go through every line, create a hash set of all the IP numbers. Save those. And then the only thing we need to do, instead of checking for one IP number, we just check your IP number against the hash set, which goes extremely quickly. And if we can find that IP number within that set, we return that you couldn't do the request. We stop it and we return true and whatever we want. And this is, again, I don't know, we're up maybe in 50 lines of code, maybe something like that. And this, together with stopping requests with empty user agents, which for some reason is quite normal. I don't know if anyone knows why so many requests are done with empty user agents, please let me know. But again, empty user agents and this list, we have seen that it stops at least 40% of all the requests we get to our client sites. Not every time, not all day, but it goes from 10 to 65. Just with this, nothing more. Well, some small other things, I'll show you them. But this is the biggest thing we get. And again, with almost no code. Nothing, almost. So little that really you should put this everywhere. And we can go one step further because we could use the same tools or lists that hackers or bots are using. Because one of the things that they use to enumerate is something called seclist. And seclists are like, it's a repo with lots of different lists of interesting things. So as you can see here, you have usernames, known usernames, a huge list of usernames, passwords, and other things. But one of them is a folder called discovery, and that folder contains a folder called web content, and that contains a folder called CMS, and in that one there is a file called WordPress fuzz.txt. And I don't know if you worry about WordPress, but it's even better if you don't worry about WordPress, because a huge amount of traffic to check whatever you have on your site is going to be request to this list. Because one of the biggest, most interesting things is to check if you have WordPress. Since it's so common, they will check if you have WordPress. So it's even better if you don't have it, but you still use these kind of lists. Because we know that all a request to one of these files, if you don't have WordPress, is a request you don't want. So we can stop all of these. And we can stop them super simple as well, because the only thing we need to do is basically the same thing we did with an IP list. We say, okay, load that list from disk in this case. It could be from the internet as well. Parse it, create a hash set of every line. And then instead of checking your IP number, the only thing you need to do is to check the path of the request. If it's within that hash set, stop it. Nothing more. And as you can imagine, this example will do exactly that. If I visit just the root, everything is fine. My cats are beautiful. And if you go to VP admin, then you can't go anywhere. Again, very little code, very simple. And there are sec lists for every major CMS or every HTTP server. So there are sec lists for Apache, for whatever, and they will be, bots are using those sec lists against you, and now you can use them against them as well. So if we take this one more step and we look at the Pingora limits, which is one more crate created by Cloudflare to use rate limits, and we see how simple it is to actually implement a rate limit. It's nothing more than this. You create a rate limiter. You say how many seconds or how much time should the window of the rate limiter be. You say also how many requests per second, in this case, you want to use. You have some kind of identifier. It could be the IP number, or it could be a user ID if they're logged in, or whatever you think is appropriate to group them. In this case, an IP number. You count up in the rate limit. One here, and if you are within that limit of how many requests you can do per second, in this case, then you stop it and you return something to tell them that they can't go further. And as you can imagine, this is what happens here. I can go to the site, I can visit it, and it works. But if I do a couple of requests, it will stop me with a red page. Again, extremely simple. And the cool thing with this is that now we have the building blocks to begin to do something much smarter than just saying one IP number, or a couple of IP numbers, or whatever it might be. Because now we can make this a little smarter. We can say, okay, if we see that one IP number hits one sec list of all the sec lists we want to have, then we can begin to rate limit. Maybe first a little, then more and more and more. So we can begin to use this to create some smarter logic that will not only stop the requests that we know are malicious, but even the things that are suspicious but are trying to get into things that you know exist. And there are many more small things we can do that don't require much code either, because you can say, okay, if you don't have PHP on your site, any request to a PHP file falls within that suspicious limit. And I can assure you that no human will try to find a .php file in the path, which means that, again, you can stop them quite easily. The same goes with dot files. No human will try to find /.env or whatever it is. So someone trying to find that path, or some bot, is definitely something that you should worry about. And you can take their IP number, begin to rate limit them. Same goes with path traversals, and path traversals can look very, very different forms. These are just a couple of them. Anything with that and the URL is something suspicious. Super simple to stop. And there are many more. Vit had a CVE where if you put something on the internet, I think with with the production code, but with dev tools, and they could find whatever, they could look at any file you had on that server because they had a vulnerability if you begin something with an @ sign, which means that everything with an @ sign, just stop it, or at least class it as something very suspicious. And there are many more things you can do. I won't go through all the Pingora crates that Cloudflare has created. You can there is a cache crate to help you create a great cache system. You can have TLS termination. There are many, many, many things you could use that will help you out. And of course, all things that I've shown you are so easy to do, so you can of course put them inside your application code. You can do it in Node, Java, or whatever you're using. So if you already know a language, why put this? Why use Rust for this? And well, there are a couple of reasons. Again, performance, etc., memory safety. But in our systems, when we put this live in some of our clients, this is a graph from Grafana. The green line is the CPU usage of our protector. And I had a hard time trying to find the first small dot there to actually take this screenshot. And this is about the time where we had around 65% of requests that were stopped. So no resources at all. Again, the bottleneck is not here. The bottleneck is further down, whatever you have on the other side. And Pingora has already support to export all metrics you want, so it's super easy to have to show all things you're doing. And since it's so easy to implement, it's very reusable. So you could say, okay, I can create one for whatever application I have. You can create one big one that can stop everything, or one specifically for whatever application you have underneath. We have created one where we can turn on and off different things, everything from geo location to stop some requests to all the things that I mentioned and more. So some takeaways from this. I have mentioned this a couple of times now, but I think it's worth mentioning again. It's super easy. 50, 60 rows of code, and you already have something that will protect you enough, or depending on how you see it, at least it will stop bots. That's most important. It won't stop a DDoS attack, but you require quite a lot of more things to do that. And if you haven't tried Rust, I think this is a perfect opportunity to do something, because again, it's not that difficult to begin with, to start to have some effect, and you can use it as a perfect way of getting into Rust and using it more. I mentioned that it's flexible since you have so much, you can use it for, you can put so much logic into your application. You could create different parts for different reasons, for different things you have exposed on the internet, and reuse it, and it doesn't take any resources at all. Of course, I know that running something on a laptop it's different than running something on a server, but still, this is so lightweight. I didn't show you the memory, but it's the same. I think the only time we saw a the usage of more memory is when we imported an open source list of all geolocation IPs you can find, and that just takes memory. But I think it was around like 400 megs, and then you have the whole world, which means that you can stop whatever country you want. Again, it's super easy to adapt. Super easy to reuse. If you don't have something already that you bought, then I don't think you have any excuse to not have something like this. And this is just everything together. And I think that this is super exciting. I mean, the web application firewalls are... there might be more fun things to do, but when you see the results, when you see how much you get from just so little code, then it's fun. So even if you're at a party and you talk to me about web application firewalls, I won't stop you from talking to me about that. And that's it. A little too fast, as always, when you present it in front of people. Thank you. That's a good question. So is there a risk of stopping anything we actually don't want to stop? We have checked with the clients we have used it, and we haven't seen any effect of that. So we're worried about that as well, since it's an open source. Well, we're using an open source repo with bots. We don't actually know exactly which bots they stop, but they haven't stopped any Google or those kind of bots. And it would be quite, you can put it like this. Good bots, the bots you want, will probably tell you who they are. So it's quite easy to accept them from any blockage, compared to the bots you don't want, which will not tell you who they are. Yeah, the bots that tell you they're good and they aren't, well, hopefully they are within that list of IP numbers. And I've seen that there are actually many more sources. I haven't tried them myself, but there are more sources that you can use to actually gather information to stop even more. So that the repo I showed you is just one of the sources we found. Anything else? Yes. Yes. Yeah. 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 I like that idea. So it is possible to make them pay for what they're trying to do, and make them slower. And I don't know. This is a conversation we should probably have with security people. I've been thinking about returning different kinds of 404s from different other servers, so they can never know which server you're trying to use. Because one way of understanding what you have behind you is to check the default 404 page a request gives you. If you have an Apache server, it's one. If you have Nginx, it's another, etc., etc. So have a random set of all those and just return them to confuse them as much as possible. That would be fun. So the question is, use Pingora to implement a API gateway? Yes, definitely. So there are crates in Pingora to, for example, have a load balancer, and I mean, you can use, since Pingora is basically, again, at least how we used it, it's a proxy. So you can put whatever you want in it. I wouldn't use it to actually serve files or whatever, but as long as you use it as a proxy, then you can do whatever you need with it. You can check if the requests are the right credentials, where it should route, if it should route to different things depending on the traffic. You could use it to strip query strings, because you know that some query strings is nothing that you looked for. You can analyze the body of a post request to actually look for malicious code or something that you don't like, and then route it to the right place. So yeah, definitely. It's an open tool. That's the cool thing. I don't know if you have tried, for example, to configure an Nginx to be a little smarter reverse proxy, and it's hell. It's so difficult to do it because it's not the right tool. And I think this, we have even thought about actually taking this and creating an ingress in Kubernetes instead of having whatever ingress you're using, because it's so easy to configure and program to whatever your needs are. Yep. Okay. Thank you very much.